Welcome to Daily Papers, the podcast where we break down the latest and greatest research into bite-sized, understandable chunks. So I have a question for you. Think back to when you were learning something difficult, like math in school. What was more helpful? A teacher who only ever showed you the one single correct way to solve a problem? Or a teacher who looked at your mistake and said, nope, that's not it, try to think of another way?
That's a great question. I think the second one, for sure. The first teacher helps you memorize a method, but the second one forces you to actually think and understand the problem from different angles.
Exactly. And it turns out the same might be true for teaching artificial intelligence. A new paper called The Surprising Effectiveness of Negative Reinforcement and LLM Reasoning explores this very idea. And the results are, well, just like the title says, surprising.
Okay, so let's break that down. First up, LLM. That stands for Large Language Model. These are the AIs we're all getting used to, like ChatGPT. They're trained on huge amounts of text from the internet to understand and generate human-like language.
And researchers are constantly trying to make them better, especially at tasks that require reasoning, like solving complex math or logic puzzles. One popular way to do this is through something called reinforcement learning.
Reinforcement learning is a fancy term for a simple concept. It's basically like training a dog. When the dog does a trick correctly, you give it a treat. That's positive reinforcement. When it does something you don't want, you might say no or withhold the treat. That's negative reinforcement. You're rewarding good behavior and penalizing bad behavior to shape how it acts.
In this paper, the researchers applied this to an LLM, trying to solve math problems. The process was simple. If the model generated a step-by-step solution and got the final answer right, it got a virtual treat, a reward signal of +1. If it got the answer wrong, it got a -1.
The big question the researchers asked was, what's actually doing the heavy lifting here? Is it the +1 reward for correct answers or the -1 penalty for incorrect ones? They decided to find out by splitting the training into two different philosophies.
For the first group, they only used what they called positive sample reinforcement, or PSR. This means the AI was only ever shown its correct answers and told, good job, do more of this. It never got penalized for its mistakes.
For the second group, they did the opposite. They used negative sample reinforcement, or NSR. Here, the AI was only ever shown its wrong answers and told, nope, don't do that again. It never got a treat for being right.
So you have one AI being raised on pure praise and another being raised on pure critique. To see which method worked better, they used a really interesting metric called pass at K.
Let's explain that. Pass at 1 is pretty straightforward. What's the probability the AI gets the answer right on its very first try? This measures how confident and accurate the model is.
But pass at K, where K is a bigger number, like 256, is different. It asks, if you give the AI 256 different chances to solve the same problem, what's the probability that at least one of those attempts is correct? This doesn't just measure accuracy, it measures the model's creativity and the diversity of its problem-solving skills.
Right. Can it find multiple different paths to the right answer? So what happened? The results were fascinating. The model trained only on positive feedback, the PSR model, got really good at pass at 1. It learned to confidently produce the one correct answer it had been rewarded for.
But that's where the good news ended for that model. Its performance on pass at 256 was poor. By focusing so much on the one correct way, it lost its ability to think outside the box. It became overconfident and less creative, a one-trick pony.
Now for the shocker. The model trained only on negative feedback, the NSR model, the one that was only ever told you're wrong. You'd think it would just get discouraged and give up, but the opposite happened. It got better across the board.
It's wild. Its pass at 1 score, getting it right on the first try, improved dramatically, almost as much as the models that used both positive and negative feedback. But where it really shone was pass at 256. It maintained its diversity and creativity, often outperforming all the other more complex training methods.
So why does telling an AI it's wrong work so well? The paper explains that when the model gets a -1 penalty, it doesn't just erase that pathway from its brain. Instead, the process is much more subtle. It slightly lowers the probability of making that specific mistake again.
And here's the key part. the probability it took away from the wrong path gets redistributed to other plausible paths the model already thought were decent possibilities. It's not learning a totally new thing. It's refining its existing knowledge. It's like the model thinks to itself, okay, that road was a dead end. Let me check my map for other routes that looked promising.
This preserves the model's diversity. It learns what not to do, which forces it to explore the vast space of what it can do, ultimately making it a more robust and flexible reasoner.
Building on this insight, the researchers proposed a new method they called weighted reinforce. It's a simple but brilliant combination of both approaches. It uses both positive and negative feedback, but it gives more weight to the negative signals.
And it worked like a charm. This balanced approach achieved the best of both worlds. It was great at getting the answer right on the first try, but it also kept its creative juices flowing, allowing it to find many different correct solutions.
So the big takeaway is that just like with people, teaching an AI to reason isn't just about showing it the right answer over and over. Critiquing its mistakes and forcing it to explore alternatives might be the secret ingredient to unlocking deeper and more flexible intelligence. It's less about memorization and more about exploration.